Hello students, I am going to start a new chapter in mathematics called integration, important part for calculus. Okay, integration. So first of all, I want to explain what is the meaning of integration. Integration, what is it and what is the use of it is. Actually, a function f of x is given. Everyone knows how to find its differentiation. D by dx of f of x. You know the procedure. For example, a function is given as some x square. You know how to find a differentiation. That is nothing but 2x. What is the use of differentiation? That is important thing. Already we did so many applications of differentiation. Differentiation as rate measure, differentiation as approximations. Okay, major importance of differentiation is finding the slope of a curve at a particular point. For example, y is equal to f of x is given. So d by dx of f of x at x equal to 2. What is the meaning of this? This is nothing but f dash of 2. What is the meaning of this? The slope of the function at x equal to 2. For example, this is the graph of the function. This is at x equal to 2. For example, this x equal to 2. At this particular point, you can find corresponding y, that is f of 2. At this particular point, if you can draw a unique tangent, the slope of that unique tangent is nothing but f dash of 2. We applied the application of all these differentiation completed. But what is this? What is integration? What is the use of integration? So it is great important in science, integration. In modern days, integration is taken as the different process of differentiation or inverse process of differentiation. Okay, some symbol is given. I will explain what the meaning of this symbol, everything. Okay, so what, for example, integral, I can read as integral x square dx means what? First of all, we should know meaning of this notation. Integral of x square dx. D by dx of x square means you know the meaning, clearly explained. Now what is the meaning of integral of x square dx? In modern days, integration is said to be a differentiation. For example, students listen. According to modern definition, for example, integral of x square dx, how I am reading, that is important. Integral of x square dx is some k of x. So in modern definition, what is saying that differentiation of k of x is nothing but x square. According to modern definition, what I can say, d by dx of k of x is nothing but x square. Okay, what means integral of f of x dx you want to find? Indirectly, what should find? You need to find a function here whose differentiation is this. Such function should find. That is called integration of that function. Okay, I will explain through example. Students listen. Integral of sin x given, integral of sin dx, notation this one. In generally in a dy dx, this is not taken as a fraction. This is not taken as fraction. Just like d by dx of y, it is an operator. But integration, it have its own symbols and notations. So integral sin x dx equal to what? So what should do here? You need to find out a function whose differentiation is sin x. Okay, for example, cos x is taken. What is the differentiation of cos x? What is the differentiation cos x? Okay, what is that? Minus sin x. Okay, what is the differentiation of minus sin x? Minus cos x, sin x only. What I can write here? I can write minus cos x. Okay, students listen. So according to the modern definition, integration is the reverse process of differentiation. So what I can say now, integral of sin x dx means I can say minus cos x. Somebody will say that somebody will take minus cos x plus 3. What is the differentiation of this? What is the differentiation of this? Again sin x only will get. So what I can say, this answer also nothing but cos x plus 3 also I can write. Understood? Somebody will write minus cos x minus 7. That also satisfied. Differentiation of this function is nothing but sin x only. So what is the meaning of that? I can write minus cos x minus 7 also I can write. What is the meaning of that? So what we are getting, outputs are not unique here. Not unique. Sometimes I can write minus cos x, minus cos x plus 3, minus cos x plus 7. So finally what I can write? Nana? So minus cos x plus some constant only, some constant, say I can see, I can write some constant. Finally, what is my discussion? According to the definition, according to the modern definition, so I can say that integral sin x dx is nothing but minus cos x plus c, where c is a constant. Okay. But what is the use? What is the use of integration? That is important. What is the use of differentiation? Already explained. What is the use of what is the use of integration? Chapter's name is integration. Okay. Okay. Listen, student. Integral fx dx means what? We need to find a new function, say capital F of x plus c, whose differentiation is f of x. Okay. But I will try to explain what is the use of integration, why they invented, mathematicians. What is the necessity to invent integration? Okay, through example I will explain. Okay, listen all of you. So according to modern definition, so differentiation and integration are reverse process. Okay, students, what I explained, integration is the reverse process, differentiation, like addition is the reverse process of subtraction, reverse process subtraction, multiplication reverse process of division. Like that, integration is the reverse process of differentiation. For example, observe, student, this is a ladder and these are the rungs. Here number 2 given, here 4 is given, here 6 is given, 8 is given. What happened? That value is increasing. 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. If you take in downwards, upwards means plus 2. If you take downwards, what happened? 2 is decreasing, no? I can say minus 2. That's why addition and subtraction are there is said to be reverse process. Similarly, this is another ladder. These are the rungs. For example, assume that yeah, this is say 2, 4, 8, 16. Okay. Now top to down, what happened? Increasing, no? 2 to the 4, 4 to the 8, 8 to the 16. Into 2. Each rung is multiplied by 2. We are getting another number whose length of the rung is equal to that product. So if you take bottom to top, what happened? If you divide, no? 16 divided by 2, you will get 8. 80 divided by 4, you will get 2. That means what happened? Division and multiplication are in reverse process. Addition and subtraction are reverse process. Like that, integration, differentiation are in reverse process. For example, these rungs, on these rungs f of x is given and this is given g of x. If f of x is differentiated, for example, you are getting g of x. If g of x is integrated, then we will get g of x. Okay. Yeah. What is the area generally in mathematics? Area. 2D surface covered by a figure is called its area. For example, a rectangle is given. Its length is L, breadth is B. I can say its area is L into B. Okay, a square is given. For example, side is S. So what is the surface occupied by 2D surface occupied by this figure? Means I can say that I can say standard definition S square, a square units. A trapezium is given. So this length is A, this length is B, this distance between them is H. I can say its area is half into H into A plus B. So these polygons have a specific formula to find areas. Area of this surface is L into B, area of this surface is S square, area of this surface is half into H into L plus B. Okay. Now our question is, if figure is given like this, if curvature is involved, how to find its area? How much 2D space occupied by this figure? Generally in olden days, means in lower classes, how I explain, just we need to draw a grid, we need to require of 1 unit side. Just we want to count how many squares it is occupies. For example, it occupies 10 squares. I can say that 10 square of 1 unit is taken as the area that irregular shaped figure. Students, this is the situation for invention of integration. How to find the area of irregular figures? This is the difficult task for mathematicians, how to find this area. That's why integration concept is invented. Students, this chapter have two parts actually. Integration of two parts. One is indefinite integrals. Second one is definite integrals. Okay, students, actually indefinite integrals is actually concept of integration. Definite integrals is nothing but application of integration. Okay, actually we need to start indefinite integral first. After that we need to learn definite integrals. But why mathematician invented this symbol and invented this chapter? To explain that, I want to use one example that is actually belongs to the concept of definite integrals. Okay, students, so just now explain how to find the area of a irregular shaped figure. So by using integration concept, you can find the area of the irregular shaped figure. By using integration, you can find the volume of solid figures also. That is be in the definite integrals concept. Listen, students, one important thing: area under curvature. Okay, just y is equal f of x is a differentiable function. Okay, so for example, its graph is given like this. This is so this is y axis and this is x axis. Okay, students, yeah, this is the graph of y is equal f of x. Okay, so two vertical lines are drawn. So this is one vertical line, this is another vertical line. So name of this vertical line is given by x equal to a and x equal to b. Actually, the main purpose of invention of integration is to find the area of the shaded region. The shaded region is not in the shape of rectangle, not in the shape of a specified figure. You can say area, shaded area is nothing but area under curvature. Okay, we want to find the area of figure formed by y equal to f of x with the x axis bounded by two vertical lines x equal to and x equal to b. This is the main purpose of invention of integration. This is the main purpose, means to find the area of this figure. How they did initially mathematicians, I will explain. What they did, first of all, they divided it into two rectangles. Divided into another vertical is drawn. Another vertical is drawn. Okay. So what they did, first of all, they found the area of this rectangle. This is not rectangle. But how they did? They dropped a perpendicular here. Here a perpendicular is dropped. So this is just looking just like a rectangle. This is another rectangle. Area of this rectangle plus area of this rectangle is taken as the area of that figure. But this is not exact, but it approximate. Okay. To get more accurate, what they did, observe. I will explain. Actually, what happened? Two things you lost here. No? This area. 1 minute, I will show you. This portion and this portion are neglected actually. For that, what they did, they do another rectangle is drawn like this. Area of this rectangle plus area of this rectangle is taken as the area of the curvature or area under the curvature, but that also not exact but somewhat approximate. To get more accurate, what they did I will explain now. Students, to get more accurate, in previous situation what they did, they drawn only one vertical line, they divided into rectangles, from that they found the area. But to get more accurate, that figure is divided into a finite number of rectangles. a finite number of rectangles. Such a way that all the width of the rectangle should be same. In my diagram is not same here, these two are different, but like that they divided. Okay, let they taken this is say x1 length, say this is take x2 length, this is the x3 length, this is x4 length, this is x4 5 length. Okay. Yeah, for example, this origin, student, this is taken as x1, for example, number like this x1. So this is nothing but f of x1. This length is f of x1. Height of the rectangle is f of x1. A rectangle is not formed. That's what they did. They dropped perpendicular. So this is taken as x1. Yeah, what happened here to here x1, but previous year to here, this length is nothing but now x1 minus a. Width is x1 minus a. Width is x1 minus a. Height is what? F of x1. So what is the area of this rectangle? F of x1 into width. Width, what is that? A minus x1. This is the area of this rectangle. So another rectangle is constructed like this. So this point is taken as x2 on the number line. Okay, this total x2 means this point becomes f of x2, height becomes f of x2, width becomes a minus x2. The area of the rectangle is f of x2 into a minus x2. Next one is f of x3 into a minus x3. They added all. For example, the area of the region denoted by S. What I can say, S is nothing but f of x1 into a minus x1 plus f of x2 into a minus x2 plus so on f of xn, okay, into a minus xn. Assume that they divide into n pieces. Okay, actually what they did, they took all of equal length, say x1 for example, all are equal to x1. So addition of this, what I can write directly, S is nothing but sigma f xi into, yeah, that xi into where I is equal 1 to n. Okay, what happened here? Finite number of rectangles. 1 to n means finite number, n rectangles. They divided the total piece into n rectangles. Important thing is this is the width of the rectangle. If the width is taken as a delta x, which is a small positive number, negligible length, then what happened? What will get the sum of the area of the rectangles is more accurate than previous. Okay, so how they wrote that symbol symbolically, S equal to sigma I equal to 1 to n into f of xi into delta xi. Okay, here n is tending to infinity. So what will get, that area is taken as the area of this region. So mathematical convenience, students listen, mathematical convenience, this one is written as this symbol f of x into dx. Here they wrote a, here they wrote b, here wrote s. What is the meaning of that? What we will get this, how to operate it, we will discuss later in the chapter. How to find the value of this, what we will get, yes, actually what we will get, I will write capital F of b minus capital F of a. That we will discuss how you got it, how to operate it. That is not big problem. Here my intention is, what is the use of integration, why they invented. Okay, so this is nothing but area of the shaded region. Now this is nothing but area of the shaded region. So these two are same. Now onwards, integral f of x dx, where x is equal to a to b, means area of this region. Area of the region bounded by the curve f of x and x axis, and between two vertical line x equal to a and x equal to b. Okay, so how you got it, how to apply it, that I will explain later in the chapter of definite integrals. Before that, we need to complete indefinite integrals first. After completion of indefinite integrals only, we will start definite integrals. Okay, understood my intention? Just what is the use, why they invented, for that purpose I explained all these concepts. So what happened, they divide the region into some rectangles of thin width. Means they divide in infinitely many rectangles. They divide the region into infinitely many rectangles. Area of all those rectangles is approximately area of the region. That is nothing but this. That is nothing but this. Okay. I hope you people understood what is my intention. Okay, students. This is summation. This is summation. That's why I used this symbol sum, sum, sum. Summation of that f of x into dx, just like summation symbol s. Okay. Yeah. Now first chapter, indefinite integration. Integral of f of x dx. We can read as integral f of x dx equal to capital F of x plus c. Just now explain. So what is the meaning of this? Means differentiation of this part, RHS part, is nothing but f of x with respect to x. I will write mean differentiation of equal to f of x. That's all. No need to write it with respect to x. Okay, clearly I mentioned d by dx. So this is the meaning, man. Inverse process of differentiation, only integration. So what is this? This is called integral sign. I will write in here in this. 1 minute. Say this is 1. In 1 means integral sign. Instead, actually that is s. Integral sign. What is f of x? Integrand. Okay, what is dx? Dx generally with respect to which variable we are differentiating, or with respect to which variable we are integrating. With respect to which variable you are integrating. Dx stand for what? Dx stand for with WRT. I will write directly with respect to which variable we are integrating. Okay. What is the capital F of x? That is interesting thing. Capital F of x is called antiderivative. Or sometimes called primitive of f of x. Primitive of f of x. Of f of x. Okay, these are some standard notations. Okay, students. Now I want to write some fundamental facts. So differentiation of some 2 is equal to 0 only. No? Differentiation of constant what? 0 only. No? Students, what I can write now? First one, integration of 0 dx with any variable equal to constant. This is one thing. Second thing, d by dx of some g of x k into g of x. What is that, Nana? K into g dash of x. Just like here also, integral of k into f of x dx is same as k into integral of f of x into dx. Okay. Next, third one. So differentiation of f function plus g function, or f of x plus g of x, nothing but f dash of x plus g dash of x. No? Some rule is there integration also. Product rule is there in differentiation, product rule also there in integration. Quotient rule is in differentiation, but quotient rule is not there in integration. That should take care. Okay. Integration of f of x plus g of x with respect to x, that is say d of x, same as integration of f of x dx plus integration of g of x dx. Okay. So actually integration of f of x into g of x, what happened, we will discuss later, Nana. So integration by parts concept that we'll discuss at last. Okay, just I am explaining some fundamentals. Integration of 0 is constant, integration k into f of x nothing but k into integration f of x, integration of f of x plus g of x, dx equal integral f of x dx plus integral g of x dx, like that. Okay, students, here some results I will write. One by one. Integration of x power n dx. Just I can say that x power n plus 1 by n plus 1 plus some constant. C stands for air constant only. Only one condition, n is not equal to minus 1. These are just we need to accept these results. Okay. Integration of 1 by x dx is accepted as logarithm of mod x plus c. Okay. So integration of x, that is nothing but fourth one. Integration of sin x dx is remembered as minus cos x plus constant. Integration of cos x dx remembered as sin x plus some constant. Integration of tan x, what we'll discuss later. You can't do none. Tan x. Okay, you can find out a function whose differentiation is this. I know that logarithm of mod secant x. Log of mod secant, differentiate it to get tan x, but I don't want to explain this concept. This is not taken as important results, that are not taken as basic results. Some basic results I will write, not instead of important results. That is better. Okay, students. Okay, now I can't take that as a basic result. Tan and cot. Okay. Yeah, sixth one, integral of secant square x dx I can take. That is equal to tan x plus c only. Yeah, seventh one, integral of cosecant square x I can take. That is just basic only. Minus cot x plus c. Okay. Like that, what is the number previous? 7, 8. Integral of 1 by 1 plus x square dx. Tan inverse of x plus c. Like that, you can take some basic results. Okay, but your intention is integration of tan x given, how to find. Integration of 1 plus x cube by x square given, how to find. Integral root over 1 minus x square, how to find. Integral 1 by root over 1 minus x square given, how to find its integration. So that is actual our task, Nana. So I will explain one by one situations. First of all, we should learn all these basic results. So based on basic results, we need to solve some problems first. After that, I will explain complicated functions, how to find integration of complicated functions. Okay. For example, example 1. Integral of x cube dx equal to dash. Directly I can say that x power 4 by 4 plus some constant. Okay, this is say example 1. Example to given. Integral of, so one more basic I forgot to write, that is integral of e power x dx equal to e power x plus c only. Okay, integral of x square plus e power x plus 1 by x dx is given provided x is not equal to 0 and x is greater than 0, or x is not equal to 0, that is better. So what I can say, this is nothing but x cube by 3 plus e power x plus logarithm of mod x plus c. Okay, so third one, integral of 7 by 1 plus x square dx should find. What I can write, 7 into integral of 1 by 1 plus x square dx. This is nothing but 7 into arc arc tan x, or 7 into tan inverse of x plus some constant c. In this way you can find the integration of some basic functions.